This is Team 2-7, and this is our DP3 report. I'm Josh Wakeling and
Rory Hanley, my uncle estate.
So to start off, DP3, let's go to the introduction, where it covers every topic from DP1 to now. So you're talking about the project management throughout, customer data, specifications, etc. And then we start to get into more specific stuff like intellectual data, failure modes, and final economic analysis. So in terms of project management, we were able to do a week-by-week breakdown using a Gantt chart and we were able to use a matrix to help figure out where we can create parallel tasks to help optimize our flow. This is the mission statements. This helps define what we wanted to do, what specifications we had, and how we were going to do it with our assumptions and stakeholders involved. This is our Gantt chart. This is how we're able to show the primary line along with any parallel tasks. These were done so we could get stuff working at the same time to better make this more efficient. And this is the matrix. This also helps show off where there are parallel tasks and where there is a very defined line of what needs to get done at what time.
Hi, this is Mayank. So I'm going to cover the customer needs. So our first customer need is the customer want to control our experiment with their cellular phone. So this is our secondary options. And the second customer need is they actually don't want to get hurt while they interacting with our project. So safety is our first priority. So this is our primary now. So this is the customer profile. It's a Ricky Bobby. He's 16, single, living with his parents, and he's also working in a garage. So his even work requires some kind of physics experience. So that's Ricky Bobby. Target specification. So we have these all target specification, which is target, easy to operate, quality of materials, average time, and rest of these. So if you go to the next slide, this is the QFM. These are all the specification along with the customer need. The numbers is actually showing is as the number is going up. So basically these are, the number 5 is going to tell this has a complete correlation between the along with the customer need, and the minimum is the minimum correlation. So as you see, the target specification, we actually choosing the technology. That's what I'm going to talk about it. So the question, the units what we have for the technology is yes and no. Basically, it's saying are we using the advanced technology or are we going just a basic technology? So in our BRG, we actually using the advanced one. So that's QFM.
So this is our benchmarkings for the first station for our ramp. We picked between Star Coaster and Space Rail. However, it proved to be too difficult to actually make, so we decided to do something a little bit more simple by going with the general idea of these two. These are the hexcalator and screw lift. These are the ideas we had for our elevator. We wanted to power our elevator with an Arduino. However, we were not able to get the pulley system to actually work with the Arduino, so we ended up using a manual crank, similar to these as well. For our projectile launcher, we had these 3 different projectile launchers we were choosing between to actually work with. We decided to go with the Visual Scientifics PT PROJ projectile launcher for our final. We made it out of PVC pipe, very similar to it. This is our intellectual property. So we looked into 5 different patents when we were doing research, and 2 examples of the patents we looked at were projectile launchers and modular roller coaster toy. Projectile launchers used an air pump, so we decided we couldn't use an air pump for our project, but in order to get the projectile launcher to shoot, we decided to use rubber bands instead. Modular roller coaster, we were not allowed to use, we were allowed to use whatever we wanted. This just gave us ideas on how to mount it to our final, or onto the pegboard for our final project. So for our concept combination table, we were deciding between things such as material, shape, the launch, assembly, and the connection to Station 2. For instance, like with material, we had like carbon steel, aluminum, wood, things like that. These were our solutions we came up with. That just matches the lines right here. And the concept scoring table, we decided after scoring, we go with the final solution, which got a score of 23, versus the other ones, which got around 16 and 17. Same thing, this is Station 2 and also Station 3. So this is our final CAD for our BRG. It includes our projectile launcher, the pulley system, and the ramps. Also included are the 2D sketches of each of the stations along with their dimensions. So, for instance, the height of the pulley system was 24 inches tall. And this is our final product that we brought to our presentation. It includes the, again, projectile launcher right here, the elevator, and then the ramps.
So I'm actually also covering the FMEA, which is the failure mode and analysis. This is the Station 1, which is the projectile launcher. So in the Station 1, I'm going to actually talk with the higher RPM number, because the higher the RPMs, we have more risks to get failure in that particular item. So for example, for this RPM, we have 150 on the item called barrier. So the barrier, we might have the potential failure called cracks, might have a poor appearance coming out, the severity is going to be 10. And the potential cause of the failure could be vibration or the overload weight. And then the occurrence is going to be the 3, and the current detection method, we actually doing the setup, some kind of certain angle so you can shoot the ping pong ball in the right area. And then the detection, we just given number 1. So if we multiply all these numbers, we'll give it 150. So this is the one which has a higher risk on that particular item. So on the Station 2, this is the pulley system, which we also call the elevator. So on the elevator, we have the RPM 150. We have is on the hand crank, because as you're cranking the material, as you're cranking the shaft, which basically gonna create some kind of vibration. So that will actually gonna affect on our materials. So the potential failure, again, crack, poor appearance, we got a vibration. The detection is gonna be the visual inspection we're gonna have, and the recommendation, we're probably gonna do some kind of fatigue test or the SNR curve test, so which we can find out that these kind of vibration will handle our material. So in the Station 3, this is the ramp. So basically we go on 180, which is on the material. Again, the potential failure will be crack, excess friction, vibration, and the current detection, we again doing the visual inspection, and recommendation action again are SN curve, or we can go with the strength test.
So now finally on to the economic analysis. This was our investment proposal. This is where we did a quarter by quarter analysis, and this is how we ended up getting our final results of what the present value of the entire project is, along with the IRR and future worth. This is the same data that we were able to use to figure out the break-even point for how many units we have to sell in order to get a final break-even to where we're no longer in the red. And next is the chart, and this is also the exact same thing. This is a scenario 1 where it is a fixed cost and it will be very linear. It's not a parabola. So this is how we were able to figure out the break-even point. So in conclusion, we have successfully finished all DP1 through DP3. We have finished our final mock-up and prototype along with any testing we needed, and we were able to get a full economic analysis along with everything else that was required. Have a nice day.